Good morning.
Good morning,
Good
sir.
morning, sir.
Morning, sir. Good morning, sir.
Yes.
Good morning. Is the screen visible?
Yes, sir.
So we were trying to plot this equation, and I asked you to do that. So today we start here. This is our lecture number 14, and today is 15/02. When is your mid-sem? Mid-sem dates?
4 to 15, sir.
Maybe in March 4th.
4th.
Yes,
No,
sir.
academic calendar has been given to you, right?
Yes,
Yes,
sir.
sir.
They mentioned from March 4th to March 15th.
Okay, March 4th is Friday. So we have 6. March 1st is a holiday, right? And so we have 3, 4, 6 classes. Okay, before midsem. So I will try to finish the dynamic analysis. All right. So we are trying to plot on this equation, okay, vectors in this equation. So 300i, let us first write down this 300i. First I draw this 300i. Okay. And then on the other hand, we know this one also. So, and you can see that the whatever magnitude it will have, and it go towards this direction. This is known to us. This is 900 by 49. Almost you can say 450. Okay. And this is in the J direction. Okay. And then we have this component which we don't know its magnitude, but what we know is its direction. Its direction is along I, right? So you draw this. Now we have to draw these two components. Uh, what is this value? Can you calculate and tell me?
Sir, 128.5.
This is 128.5, and this goes in the I direction, right? So you take from here, we have this is in the I direction, 128.5. Let me write that 49 into 175, and this is in the I direction. That component we have drawn now. The next component is So the next component is this one, 36 by 49 into 50. What is this value? Almost 30,
36.73.
33,
36.73, sir.
36.7, whatever
Yes.
may be. And it is negative. So we need to go down, right? And let's say I go this much. And we will write it 36 by 49 into 50. And it is in the j direction. Say minus sign. Okay. This is also minus. So we have now plotted this. Now you tell me about this vector. What is the direction of this vector? Can you tell me? See one thing, this alpha AB, if you take this common minus alpha AB, then you have 175 or 50 I minus 170 plus 175 J, right? Okay, hello. So one thing you see, it's a, if you just can say, see here, it's a equation of a straight line, right? 50 points you go in this direction, uh, I direction, and 175 you go in the J direction. And if you just take the negative sign, so let us say that we have 50 distance, you go this side, and then 175, and maybe, okay, this is the, what is the direction? You tell me.
Sir, minus 74.05 degree.
Huh?
Minus 74.05 degree.
Minus 74.05 degree. This minus you have taken care.
Yes, sir.
Now see one thing. If we go back to its calculation, from where it came, what is this terms? It came from this, right? Alpha AB cross this, right?
Yes, sir.
So what is this vector? Minus 175 I plus 50j. What is this vector? यहाँ से बताओ कौन सा वेक्टर है ये?
AB.
R, right? R B A, right? है ना? देखो RBA minus 175 I plus 50j, है ना? This is RBA. That means from this point to this point, vector is from this point to this point. You are pre-cross multiplying with omega AB. ये कहाँ गया? This quantity, right? Alpha AB into RBA. What is the direction? Alpha AB into RBA. Alpha AB into RBA. What is the direction? Alpha is perpendicular to the board and coming out. So if you, and your RBA is in this direction, that is RBA in this direction. And we have taken alpha AB in this direction. Okay, alpha AB. If it is a vector, you can say alpha AB in the K. ऐसे लिखा है ना. Now if you do cross multiplication, what is the direction? the direction of that cross multiplication is this, right? Perpendicular to R. Yes?
Yes, sir.
Yes, sir.
The direction is perpendicular to the coupler. Okay. So this whole quantity, maybe, I hope we have not done any mistake. This whole quantity would be perpendicular to the coupler. So I'm using this red line and we draw a line which is perpendicular to the coupler. So from this point, we have drawn this new line, which is alpha AB cross multiplied with RBA. Okay, and they intersect at this point. So that means now you have, this is the value for your minus 100 alpha AOI. Okay, from the chosen scale, you can find out what is AO, right? Obviously, AO has to be negative. Is it not? AO has to be negative from here. Okay.
Sir, magnitude of 36 by 49 into 50 is greater than 900 by 49 now.
Uh,
Yes, sir.
what is this value?
सर डबल अप्रोक्स सर
हाँ?
अप्रोक्स डबल हो गया अप्रोक्स वैल्यू डबल है कंपैरिजन में
ओके, ठीक है, इसका वैल्यू बताओ ये कितना है ये?
एटीन पॉइंट 36
18.36. Okay, and let me redraw it. No problem. And what is this value?
36.49
36.49. So we draw a line like this, which is 36.49. And finally, we have the direction of this one. Direction of this one is perpendicular to the coupler. That means they intersect here. This is alpha AB cross multiplied with RP. Okay. Once you have this, then you can say that this minus 100 OA is equals to this. Okay. This is minus 100 OA. And for this length, you have this equation. From that, you can find out what is alpha AB. So for, you can see that this alpha OA is negative. So from here, if you measure, you will get that. And what is this acceleration? This point represents the acceleration of which point? If I have a vector like this, what is this vector representing? Which acceleration? Which acceleration? Acceleration of point A, right? Oh, you are saying acceleration of OA. Okay. O point's acceleration is 0. That means that is the acceleration of point A. And then that's what we have discussed in the last class. You see, acceleration of A is nothing but acceleration of this acceleration, OA or AO, whatever may be. Okay. So this diagram, you have learned how to draw this diagram in your previous semester, right? ऐसे ही तो करते थे ना क्या? कोई दूसरा मेथड था तुम्हारे पास?
Yes, sir.
This method you followed?
नो
Yes, sir.
सर,
हैं?
सर इक्वेशन से नहीं करते थे.
Yeah, equation से नहीं करते थे, but the steps are like this, right?
यस सर.
You have this is known, then this is known. What you have here, this is the, I mean, if we consider this is the acceleration of point B. First you have drawn acceleration of point B. For acceleration of point B, you have a tangential component and a component which is along the length. Okay, so this is the component which is along the length. This is the component, not this. This is the component which is along the length, and you have a component which is perpendicular to it. Okay, on all other terms this way. Okay, so in our case, we have drawn this one, but this is not necessary. You have to use this equation, form this equation, and you get the values, okay? Alpha AB and alpha OA. The advantage is, as I said many times, the advantage is when you draw a acceleration diagram or velocity diagram, that acceleration and velocity diagram is valid for that particular crank angle. Okay, how much it has rotated, this crank, how much it has rotated, it is valid for that only. In the next instant, when the crank is rotated to some other angle and the other position of these links will also change. Okay, and depending on that, the velocity and acceleration of these points and these links, they're also changing. That change you cannot find out from the same graphical method. Sorry, same graph you cannot find out that. The moment the crank angle changes, this diagram will also change. So for each crank angle, you have to draw this diagram to get the desired accelerations, or you aim to calculate some acceleration. You have to do this, draw this diagram for each configuration of the mechanism. Now, if you use this analytical method, what happens? You have two equations, okay? This equation and this equation. These two depends on the crank angle. How these two depends on crank angle? They will depend on where we have defined these vectors, okay? R, B, R, B, A, okay? If we can write down in terms of the crank angle, these vectors, if you can write down in terms of crank angle, then everything else, is same. You have to just do the calculation using those vectors, and you get the values of these unknown variables. You get the values depending on the crank angle. Okay. We will move to our next example, which is this. Maybe we call it example 2 or example 3. So we have, actually this is example 3. We have given you two more problems. In this mechanism, there is a support from where a link is connected, and the link looks like this. So at this instant, this angle is 45 degree, and this link has a slot within it. And in this slot there is a pin. This pin is connected to another link which is like this. And it is hinged at this point. Here it is hinged. The dimensions, now you can see that if we give name, this point is C, this pin is A, this point is O, hinge point is O, and OD is the link. You can see that when the mechanism is running, that means if I say this is the crank and it is rotating with omega angular velocity, then this pin with respect to this link is changing its position. That means the distance between OA is not a constant. Okay, let us give you all the dimensions. From this point to this point, this distance is 450. From this point to this point, this distance is 225. Also, from this point to this point, this distance is also 225. Okay, as I said that this angle theta equals to 45 degree, and omega of this is given to radian per second. Okay, another information given is this AC is horizontal. So when we give these dimensions and angles, all those are at this instant. Because at the next instant, this distance OA will change, the angle will change. Obviously, the distance between these 2 points and this will not change. Okay, here we have to determine. Here we have to determine the velocity of pin A and relative velocity of A with respect to t, and relative velocity of A with respect to OD link. Okay, this is the first part of the question, which is related to velocity. We will have another part which is related to acceleration. Let us first solve this velocity problem. Okay, so for ease of calculation, we attach a coordinate system. We use two unit vectors, and according to these two unit vectors, this direction we call it I, and perpendicular to that direction is J. So where is our K? K unit vector, which direction?
Perpendicular to plane, sir.
Out of the paper.
Out of the whatever.
नहीं ठीक से बोलो.
No,
I is
into the
this
paper.
direction. No, I is this direction. J is direction. Where is K?
Into the plane.
Inside the plane, sir.
In what? Into the
K,
Inside
K
the
is into the plane. ठीक है? Now, if I want to write down what is the and this unit vectors, they are rotating with this link OD. Okay. Let us now use those equations which we have used earlier also for velocity of point A. What should I write? Velocity of point A. Suppose I start from point O. What should I write? Velocity of point A.
VO plus
Velocity
VAO.
of O.
V. बोलो. V.
VO plus VOA.
VOA. No, not OA. VA with respect to O. Okay. So in this case, you can see that the O point is a fixed point. So this velocity is equals to 0. That means we only have VA with respect to O. So what are the components of this VA with respect to O?
Sir, omega OA
I
cross.
component only.
Omega. So if I write this omega OA, nothing but omega in the K direction. Okay. So I'm writing it omega cross. What should I write? R
RAO.
OA.
OA.
है ना? ROA. ठीक है. Plus anything else left?
dr by dt.
dr by dt.
V relative.
V relative. V relative
Yes, sir.
of link
E-
OA. है ना? OD जो भी लिख सकते हैं. V relative. This V relative term. So now omega is known to us. This is 2K. And what about ROA? ROA, what is this distance?
Sir, not fixed, but at this instant, 225 root 2.
225 root 2. We have to give the direction. Take it. So I am writing here. This is 225 root 2 I. First component. Now you tell me what is V relative. Actually, we have to find out V relative, right?
Yes, sir.
Yes, sir.
We have to find out V relative. V relative OA. Can you do this calculation? First term. This one. Ki is J. And this is
450 root 2.
450 root 2. Now, the another way to find out VA, what is that? If I start from point C, so velocity of point C and velocity of A with respect to C, right?
Yes, sir.
Yes, sir.
So this velocity of C is equals to 0. And what about velocity of A with respect to C? Is there any relative component? So we have omega CA cross R CA plus, if I write V relative CA, then you can see that the distance between CA is always constant, right? That is not changing. So there is no relative velocity. We have only this component omega CA cross RCA, where this omega CA is not known to us. Do we know this?
No, sir.
We don't know omega CA. So let us call it omega CA, and it is in the K direction. Okay. That multiplied with RCA. So the next task is to define what is RCA in terms of Ij. Okay, so here in the previous equation, this V relative OA can be written as, what is the direction? Do you know the direction of this V relative OA?
Sir, I cap में.
I cap hai. And let us call this, this is some x dot, okay, some value, and it is in the I cap direction. Okay, just this is also unknown. Just to uh, say that there is a some value which is a velocity, and its direction is I direction. Okay. Now, so why I have written? So we want to write it in terms of I and j. So here we can write down x dot I. Is it fine?
Yes, sir.
Yes, sir.
Now come back to this. What is the definition of RCA? You have to
So
go to this
225 by root 2 in negative y
225,
direction and 225 by
225 by root 2 in
negative
negative
y
y
direction and
direction and negative j direction.
is j direction. Yes.
Okay. So RCA we have defined. Let us substitute it here. 225 by root 2 minus I minus. Can we do the multiplication? So this is 225 by root 2 omega CA, and then we have K into I is minus J, and K J is minus I. ठीक है? ठीक है?
Yes, sir.
Yes, sir.
So once we have done this, now we have to use this to relation to, because this VA are equal, so we can write it this way: 450 root 2 j plus x dot I is equals to 225 by root 2 omega CA I minus j. ठीक है? Now if you just separate coefficients of I cap, so you have x dot equals to 225 by root 2 into omega CA, right? And coefficients of j cap 450 root 2 j is equals to minus 225 by root 2 omega CA. Now j क्यों लिख रहे हैं, है ना? So can you tell me what is the value of omega CA from this?
Sir, 4.
4.
This is
Four.
4. Let
Four,
me
sir.
check my note.
-4.
This is
-4.
-4 radian per second. Okay. When you substitute back it here, what is x dot?
-450 √2.
225 by √2 into 4, and there is a minus sign. So what is this value?
-450 √2.
Minus 450 √2. And this is, if everything is given in millimeter, so this is in millimeter per second. This is the answer we have, right? The V relative. V relative is equals to x dot, which is minus 450 √2. What do we mean by this minus 450 √2? The relative velocity direction is opposite to I direction, right?
So it is moving along -I cap.
Yeah. So this way from here, what was the question? Determine the velocity of pin A. We have not got this velocity of pin A, but we have got this relative velocity of point A with respect to OD. Okay. Now we will find out what is the velocity of point A. Tell me how to find out this. What is the velocity of point A? We can just use any of these equations and get the velocity of point A. Okay, which equation you want to use? Let us use the second equation. 225 by √2 into omega CA is 4. That is a minus sign. And then I minus J. Again, this is the same value, right? 450 √2 I minus J. So what is the value of the velocity? Just magnitude. कितना होगा magnitude?
900.
900, sir.
900.
-900.
Minus 900 has no meaning. When we say velocity, it is the absolute value we are taking, right? And now what you do, this minus sign will not be there. You have to use this square plus this square. So all the minus signs will not be there. You have just this 900 millimeter per second. Okay. Now we come to the next discussion. We now have to determine the angular acceleration of AC.
Sir, there was one more part. Velocity of A with respect to D.
There is, बोलो क्वेश्चन बोलो, मैं सुन नहीं पाया.
Second
Sir,
part of
there
the
was one more
question.
part. Second part.
No,
We have to
that is the, okay, that is this is relative velocity of A with respect to OD is nothing but V relative.
with respect to OD. Okay, sir.
With respect to OD, what is the relative velocity of A? That is nothing but the V relative. ठीक है ना? Now let me write this question. Determine the angular acceleration of AC and the acceleration of A. acceleration of A relative to the rotating slot OD. In this case also, actually what we need to find out, we need to find out what is alpha AC and what is the acceleration of, actually relative acceleration of OA. Okay, these two things we have to find out. Again, we will use the similar method. So first we will write down what is the acceleration of point A. What should I write here, please? Bolo.
Acceleration of O.
Acceleration of O.
Acceleration of AO.
Acceleration of A with respect to O. This is one equation, and the other equation is acceleration of point C plus acceleration of A with respect to C. Okay. Now if we write down this properly, the first equation, what are the two components? AO is 0, right? That is a fixed point, and we have to write down this. How many components are there here in this equation?
Four.
4 components.
बताते जाओ, एक एक करके बताते जाओ. Alpha
AO
cross R plus
Omega
R plus
twice
plus
A relative of OA.
ठीक है. So let us calculate that first. I am putting it here. Okay. So acceleration of point A. Now tell me what is alpha OA, AO, alpha OA, or what is the angular acceleration of this link OD?
0.
This
Because
is 0.
omega is constant.
0, that means this is equals to 0. That quantity, no need to take care of this quantity. And then what about the other terms? Let us write down. What is omega? This is 2k into ROA. What is this? 225 क्या था बताओ?
√2I.
225 √2 I plus 2k. What is V relative OA? क्या था? -4.
minus 450 root 2 I cap.
Minus 450 √2 I cap. ठीक है. Plus A relative. This we need to find out. In this case also, again, you can say that this acceleration is in which direction? Relative acceleration of point A,
I direction.
I direction. So let us write down this as x double dot. Double dot represents acceleration, x double dot in the I direction, right? So here we have used relative OA is equals to x double dot direction. So take, let's do this calculation. Ki is j, so you have plus sign, and then kj is I, you have a minus sign. And if you multiply this, बताओ ये कितना होगा?
900 root 2.
900 root
900
2.
root 2 into j direction. नहीं, ki is j I direction. Plus, what is the next term? 4 into 450. कितना होता है?
1800.
1800 root 2.
1800 root 2 into ki is j. Negative sign होगा ना?
Yes, sir.
Plus x double dot. This is in the. So here only unknown is this x double dot. These two are known to us. Let us now use the other equation. What about this term? This is 0. How many components are there with it? Let us write down all the components, then we'll see which one is necessary here. Okay. So this is alpha AC multiplied with RCA plus omega AC cross omega AC cross RCA plus 2 omega AC into B relative AC plus A relative AC. These two components are not there. This V relative is 0, A relative is 0, right? But we have all these components present here. Okay, so now is equals to alpha AC. Let us take its direction is K multiplied with what is this RCA? If you remember,
225 by root 2 minus I direction minus j direction.
plus omega AC is known to us. Omega CA
Minus 4.
4K. So this is minus 4K cross multiplied with minus 4K. RCA is 225 by root 2 I minus J. Done? Do the calculation and tell me what should I get from here. If I just take this 225 by root 2 common, because मल्टीप्लिकेशन में नहीं चाहिए हमें, ठीक है, पूरा से कॉमन ले सकते हैं ना. नाउ टेल मी फर्स्ट मल्टीप्लिकेशन. दिस इज k into
Alpha
r,
AC minus j.
alpha AC
AC minus j.
alpha AC
Plus I.
now here also we have kj is I, but this, so I'm writing again here alpha AC. Is it fine? ठीक है.
Yes, sir.
So this now let us do it in 2 steps. The magnitude would be 16 we have taken care of this minus and this minus, so it will become plus 225 by root 2 we have taken common. Now if you just multiply this k into I, you have k into I is minus, means here you get minus j, and k into j is I minus I, so you have I, and then k, this minus is not there, k into j, so you have plus I and ki is j. Is it fine?
Yes, sir.
ठीक है?
Yes.
Once we have these two, then from these two, this accelerations, if you we can equate 225 by root 2 and alpha AC I minus j plus 16 I plus j. This is equals to यहाँ पे भी ऐसे ही कुछ है, minus 900 root 2 I minus 1800 root 2 j plus x double dot I.
सर
हाँ,
सर वहाँ पे k क्रॉस j माइनस आई होगा ना?
यहाँ पे
हाँ
देखो this minus we have taken out.
आउट
K
यस सर.
cross j is minus I. K cross j is minus I. So this become plus and
Yes.
Ki is j. ठीक है?
Yes.
Now just take coefficients of I. क्या मिलता है हमें? So
सर
this
k
is
I is j ना सर. So
हाँ, Ki is
minus
j.
will be there ना.
K कौन सा, ये वाला
Yes,
बोल
that
रहे हो
only
इसके
answer.
साथ? ये इसके साथ बोल रहे हो?
Yes sir.
So
K I.
सुनो, K into j gives you what? Minus I.
Yes sir.
So that minus and this minus cancel. So
Plus.
here we have plus I. Then you multiply K with that plus I. Ki is simply plus j.
अच्छा. Okay yes sir.
ठीक है? So we have alpha AC plus 16 is equals to minus 900 root 2 plus x double dot. In this, there are two unknowns. Now, if you just take coefficients of j, so it is 225 by root 2 alpha AC plus 16 is equals to minus 1800 root 2. Can you please calculate this alpha AC and tell me what is this value?
Sir, alpha is C16.1.
ओके नहीं, यहाँ पे लिखने के टाइम पे हम लोग कुछ गलती तो किए हैं. यू हैव टू मल्टीप्लाई दिस विथ 225 बाय रूट 2. यहाँ पे भी 225 बाय रूट 2 है ना?
Yes, sir.
नाउ यू टेल मी व्हाट इज द वैल्यू?
32.
32 radian per second square. Once you get this 32 radian per second square, you can find out what is x double dot. Tell me what is this value? Tell me what is this value? मिला कि नहीं?
Hello, sir.
हाँ.
So while equating the J component in LHS side, it should be minus 225 by root 2 alpha AC. But instead of that, we have written plus.
Yeah, it is minus. You guys got this 32 using minus or plus?
So using minus.
Yeah. Because my note is saying that it is 32 radian. I did a mistake here. So what is this value? Tell me.
The 8909.5.
89.
09.5.
You say 8909.5. In my note, it is 8910. That's fine. Okay. Now I give you this task. This is your home assignment. You so home assignment is draw the acceleration diagram. Draw the acceleration diagram using graphical method and using the vector equation. Okay. So you have learned how to draw acceleration diagram graphically. Do that, and then you just use this this relation. Use this relation. Use this relation. When you will use this relation, you see, or you can go further. You can start from here. Okay, so that you know which one is which component. This is the component which is your along the link length. Okay, this is a component which is perpendicular to the link. This is a component which is along the link. Okay, on the other hand, you have this component. This component is perpendicular to link length, and this component is along the link length. Okay, using these you can find out the unknown quantity, that is the A relative. Okay, unknown quantity. Also, in some question it may be asked that what is the relative relative velocity, relative acceleration you got, but it may be asked that what is the co-release component of acceleration. Okay, You can see from here, this is that component, Coriolis component of acceleration. This component is the Coriolis component of acceleration. Okay, so with these two examples, and we have taken three examples actually. With these three examples, we have started with the analytical method. Okay, here we derive what is how to take derivative of a vector, and then we show you how to get velocity and acceleration. What are the terms which involve in velocity and acceleration? We have discussed this 5-term acceleration formula, the physical significance of each term. Then we have taken a example. This is our example 1, and this class, this is our example 2. Okay, and we have taken another example. This is example 3. So in these examples, we have covered the significance of each terms. Now the examples, you can have other problems, but they will revolve around these calculations only. I have thoroughly discussed where to put a, see, when you are calculating accelerations, you have 4 acceleration terms, and you know which one is relevant to your problem and which one is not. Similarly, when you do the velocity calculations, that time also you know that there are 2 terms in velocity. One is the due to rotation, another is due to change in its length. Okay, so one is your, and these 2 components, one is perpendicular to the link length, another is along the link length. Okay, so first of all, what you will do, the 3 examples which we have taken in the class, practice these 3 examples for several times. Practice these examples only for several times. Understand what is happening, because the subject, once you have practiced, you will know that, okay, I have progressed, some progress is there. But when you will come across some complicated problems, then you will see that their understanding, you have to grow with your understanding, and that growth is possible only through practice. Okay, some of the problems I have given in my web page, institute web page, there is the problem sets are given. From that problem set, please solve some problems to go deep into this subject. Okay, prepare yourself for the exam. So next day we will start dynamic analysis. Right, I think I can complete dynamic analysis in 3-4 classes. Then we will start gyroscope. Okay, in the beginning classes, the topics which we said to discuss in this, so number synthesis we have completed. The class is over. If you guys want to leave, you can leave. I just am here. Dimensional synthesis we have completed. Kinematic analysis today we have completed this. And the next thing we will discuss is dynamic analysis. My target was to complete gyroscope. Flywheel, Dr. Sahu said that he will teach flywheel. He will teach flywheel in the design of machine elements. So he said I should not teach you this, but I will teach you a little bit. Okay. All right. Thank you for your attention. Tomorrow we will start the dynamic analysis. All right. Thank you.
Thank you, sir.
Thank you, sir.